Hello and welcome to Physics 3204 for people. I'm your host, Cameron Reid, and today we're going to be taking a look at a pretty devious question that I thought up of. Before we get into the actual question, however, we do have to collect some data. For that, I have my trusty stuntman, Damian Reid. I will show you the data now. 160 centimeters, so about 4.6 meters. This is about 220 centimeters, which is 2.2 meters. Alright, this is about 221 centimeters, or 2.21 meters. Alright, so now that we have the motion out of the way, we can finally ask the question. Okay, so we all saw that there was an amazing shot from a bicycle that Damian made. Now, he was able to make the basketball shot from the bicycle. That's all well and good, but he did it from about the halfway point, right here. What if he took the basketball shot right here? That is our question that we are going to answer today. So let's get started. Firstly, we have to take a look at the thing from a one-dimensional standpoint, relative to the ground. If we take a look at it from relative to the ground, then we'll be able to look at the bicycle part afterwards. Right now, we have to figure out in this triangle what this arrow represents. We already know the time because the time is taken from the video. As well, we also know the dx because we measured that already, and the dy. The dx is how far we are away from the basketball net, and the dy is how high up the basketball net is. The acceleration is always gravity, and the time is 2.3 seconds. Our v1y, v2y, and theta can all be calculated with these three numbers up here. Firstly, we use a kinematics formula to calculate v1. We use dy equals v1t plus 1/2 at squared, and we plug all the numbers in. Make sure you don't forget the squared at the very end of the at squared. It's very crucial to solving the equation. At the very end, we figure out that v1y is 12.2380 meters per second, which, kind of makes sense because it's throwing pretty fast. Then we have a look at our next equation. v2y equals v1y plus at. Preferably, I would have preferred to not use an equation that used v1y. However, I could not find any equation like so. Therefore, we do have to use our calculated v1y, which is a little bit risky in physics, but sometimes you have to take risks to get results. Anyways, we calculate with our negative free fall, and that gets us the total of negative 10.325 meters per second. It's calculated using our equation earlier with dx and t, because x is always uniform motion. Vx equals dx over t. Vx is equal to 2.2 meters over 2.3 seconds, which Vx net would equal 0.9565 meters per second. What does all that mean? Well, it means that when we make a V-net triangle, like so, to find the V total net, we'd have to do V net squared plus V net squared, one of them being y and one of them being x, and the grand total will be our total net squared. Therefore, when we do the whole calculations, we would get 2.1388 meters per second. But what about our angle? Our angle is pretty interesting in the fact that we have to use tan to figure that out. Now, tan theta equals Vy net over Vx net, which is equal to 1.913 over 0.9565. Nerd talk over, this is about 63 degrees. There's a lot of calculations, but to be fair, it's probably one of the more interesting questions I've been asked. Now we come back to this question here. Now, initially, we were looking for this angle. But now, we know what this is and we know what this is. So now we can find our hypotenuse with some simple Pythagorean theorem, which gives us an answer of 2.2508 meters per second for our V net. And then we have our tan theta, which we use to find our angle, and our grand question has been answered with a V net of 2.2508 meters per second north of east. Now that that's out of the way, and all that physics talk has melted your brain, here's a video of a bunny. Now that we've got all the boring physics talk out of the way, let's talk about something a little bit cooler. Music. Now, music is pretty cool. Listen to this. Isn't that cool? I created that. Now, why did I create this? What does this have to do with physics? Well, let me explain. It has to do with our experiment. It starts out with our build-up. Our build-up, which is our stunt driver, Damien, taking his first steps on the bike and getting ready to go. That second part there, the do, is basically our driving past the middle and shooting the basketball. With the last part being Damien stopping at the bottle. Now, it might seem a little abstract, but that's because it is. It's very abstract. However, I still think it's a pretty cool little musical piece, and honestly, I really do like it. Here's one more listen to it. Thank you for watching this physics video. Take a like and subscribe if you like this content, and be sure to share it with all of your friends. Have a good day.